Hey everybody, welcome back to the Electronics Workshop. Boy, I've been out of this shop for a little too long, so I'm getting a little rusty and I had to get back into it. Yeah. I had a couple of the industrial control remotes come in and I needed to get through a few for the local farms here. But I ended up running into an issue that I kind of ran into previous where the remote controls for this particular system would no longer power on, and I was really struggling to kind of figure out what was causing the issue and how the power on function of this board works. So I'll give kind of a quick, hopefully not overly nerdy breakdown on how this works. So you have your power button over here, you have two wires, you got your long wire coming around going into the NAND gate, which this is a CD4093, which is a quad 2 input NAND Schmidt trigger IC. Now I'm not even going to pretend to understand that circuit really, to be honest with you. It's something that is a little bit above my normal logic level work, but it's just a really interesting design. So looking at some of the breakdown here, and they were kind of your example circuit on how it works, and putting capacitance on certain areas, and anyway, I ended up... I should really read this article. That looks like it would shed a lot of light on it. But anyway, the way that this does work, apparently, is your power button comes in, goes through the trace over here, goes into pin 1 and 2 of the NAND gate. Then on the other side where you have your wire, that your through hole on here, you have another trace that comes around, goes through, and then ends up connecting to a small via under this resistor here. And then that resistor connects to the NAND gate on pins, what is it, 1, 2, 3, 4, 5 and 6. Yeah, through pins 5 and 6. I have an example board here. Yep, 5 and 6, but then it has a loop back to the pin 3 as well. So there's some, must be like some comparating circuit or a latching type of circuit with the power button pushed. It must latch it on or latch it off. Well, I ran into one of the weirdest problems. It wasn't turning on, but if I manually turned down the voltage regulator or applied the 5 volts directly to the circuit, the remote would work fine. So what that told me is somewhere in the power on function of this remote control, which is pretty much power buttons over here. You have a 2-wire connection that comes back. It sources its power directly from the battery itself. So you have your positive 9 volts going into this Schmidt trigger, and then it somehow uses that as its initial latching. It then somehow feeds it through this circuit into this CD 4093, which runs on the 5 volt side of the circuit, and then I think that operates maybe the pulsing side of this. I guess. I don't know. It's weird. It's very, very weird. I'm assuming that's how that works because there's a transistor here, a resistor, you got another transistor. So I'm kind of assuming that this is an oscillator, in a sense, with how they have this set up. I could be wrong. There's another mica capacitor right here, and there's a mica here. This mica is on the feedback pin of the voltage regulator, which is kind of still fed from here around into there. It's very weird. Anyway, so what I was finding was when I was using my multimeter to test out this circuit a little bit, when I had my meter on the ground plane and when I had it on this resistor while I was testing the power button function to take the readings and see what is it doing, what am I getting, the remote would turn on and then it would function. And then if I hooked it up that same way again and I pushed the power button, it would turn off. So the only thing I could think of was, I know multimeters can sometimes provide a little power, and maybe it was enough to kickstart the circuit. Also, I know multimeters can provide a bit of capacitance to a circuit. So I was like, okay. How much capacitance could a multimeter be introducing into a circuit to allow it to kind of maybe function or not function? So I started with this is a 10 nanofarad ceramic type, and I ran it from here to the ground plane, which you can see on this remote control. And the remote's been working. So for whatever reason, adding capacitance to this circuit makes it work the way that it's supposed to. So I guess that proposes my question of why. Why would that added capacitance, why would the meter be affecting the NAND gate Schmidt setup here in a way that makes it function, that with it out of circuit makes it non-functional? The only thing I can think of is maybe it was some resistor drift and there were some problems there. Well, I checked all the resistors that are in that circuit and they all read well within tolerance, which is perfect. Awesome. There are two mica capacitors in the circuit, C4 and C2, and I've tested those and they're kind of all over the board on their capacitance. Some read as low as 12.3 is it 12.3 nanofarad or picofarad? I'm going to just take a quick sample here. Okay, I have 8 almost 9 nanofarads there. And on this one we have 42 nanofarads. So they're not really identified in a way that kind of says, hey, this is what the capacity should be. I don't know what's good or what's not good. This one's 43. This one's over 18. So I don't know if there's just enough drift in those that it makes the circuit not work, or if they need to be matched in a certain way. But for whatever reason, adding that capacitor made the circuit work. So to just make sure that I'm not an idiot, which is usually the most important thing to try to do, I'm going to put a battery in this remote and show you. You know, we have no power activity here. I'm going to push the power button and it doesn't turn on. But if I hook a multimeter up and do ground to ground and then I touch it to this resistor here, I'm going to have to chopstick this, and now I'm going to push the power button. Oh, call me a liar. Let's go back to, I was on the voltage setting, wasn't I? Yes, we'll try that. Let's do this again. There and there. We have 7.07 volts on that side of the circuit. And if I push the button now, yep, okay, it's at 0 volts now. The remote's on. And it's going to work fine, but I can't turn it off. So, odd. So I can take the battery out. We'll put the battery back in. And I can't turn it on. So, okay, well, let's just go ahead and quickly tack in a small capacitor and give it a little help, I guess. No, probably not a bad idea. Let's take the battery out. Okay. And okay. And then we'll tack that to the ground plane. On the circuit. Make sure nothing's touching. Looks good. Okay. Now we'll put a battery in. I swear if this starts working, I'm going to be very, very confused. And then the remote works. What the hell? Anyway, for whatever reason, adding 10 nanofarads of capacitance across this point to the ground plane is enough to make the whole thing work and be happy. And I don't know if it has something to do with another portion of this remote that has failed. There are a few other capacitors in the circuit. You have a capacitor here that's your filtering from the battery through the rectifying side to make sure if you plug it in either positive or negative flipped, it doesn't matter, it figures it out. So that's not it. Goes into the regulator, does its regulation stuff, and you have your triggering stuff. So the only capacitors that are on this are main filter. You've got 2 silver mica ones here, and you have a couple of polarized ones here. 1, 2, and 3 that are polarized. So I don't really know. Let me see where those polarized guys go. We got... Let's take a look at that. That guy runs to here, and that runs to that pin. Okay. And then that one runs to the button itself, and that. Again, that's got to be an oscillator. We have a capacitor there. That has a via to the ground plane, and the positive to the button ground, or the positive side of the button. Very, very weird. That is for sure. So yeah, I don't know. There must be a problem with these silver micas or something. And I know that silver mica capacitors can kind of go bad. They can fail, and I've had them fail in older radios where with the tuning circuit the IF kind of coils and stuff, they'll have a problem with silver mica disease. I'm wondering if these are having the same issue. So I don't know. I'm spitballing here, but I did come up with a solution that seems to work, so hopefully this is a viable for the future solution. But until then, we'll just go ahead and roll with it. Let me know if you have any thoughts on this, on why in this particular case adding some capacitance to a NAND gate for a latching power function would make that work, where it obviously worked without it before. What would have failed? So cool. All right, hope you guys enjoyed. Hope you can help me out with this one, because my brain hurts. And we'll catch you in another nerdy moment. Later for now.